Hello everyone. Welcome back to Dr. Lou's VCE Chemistry channel. Today, let's learn together about the 2021 VCE Chemistry Examination 2021. We will focus on questions related to electrolysis and rechargeable cells. Electrochemistry is one of the most difficult sections in VCE chemistry. Another is spectroscopic techniques to analyze organic compounds. My explanations may need to be revised. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. Rechargeable batteries act as galvanic cells during discharge and electrolytic cells during recharge. The recharge reaction is the reverse of the discharge reaction. So, A is correct, and B is eliminated. Rechargeable batteries don't require a continuous supply of reactants. So, C is eliminated. As temperature increases, side reactions of all cells including rechargeable cells increase. So, D is eliminated. Compare electrolytic and galvanic cells. In electrolytic cells, the cathode connects to the negative terminal of the power supply. In galvanic cells, the cathode gains electrons and is a positive terminal. So, statement 1 is correct. Electrolytic cells convert electrical energy into chemical energy and are non-spontaneous. Galvanic cells convert chemical energy into electric energy and are spontaneous. So, statement 2 is correct, and 4 is eliminated. In any cells, oxidation occurs at the anode loses electrons, and reduction at the cathode gains electrons. So, statement 3 is eliminated. Finally, A is correct. 1 mole electron is equivalent to the Faraday constant. We know the total charge, so calculate the mole of electrons through the total charges divided by the Faraday constant. Please note that 5 minutes is a nonsense condition here. When the lead-acid battery is discharged, Pb and PO2 are converted into SO4. The recharge is reverse discharge. So, SO4 is converted to Pb and PO2. Reduction occurs at the cathode. The reactants should gain electrons. So, A and D are eliminated. When the lead-acid battery is recharged, PO2 is not a reactant, but SO4 is a reactant. So, C is eliminated, and B is correct. The oxidizing agent gains electrons. Pb is metal, and metal always loses electrons. So, Pb doesn't gain electrons, and A is eliminated. When the lead-acid battery is discharged, PO4 gains electrons to produce SO4, so B is correct. Please note that H2SO4 doesn't play as an oxidizing or reducing agent, just provides SO4 ions. Oxygen is added to a container, and the pressure of this container is increased. Using the universe equation of ideal gas, we calculate the mass of oxygen step by step. The answer is C. 1F is equivalent to 1 mole of electrons. So, 320 F is equivalent to 320 mole electrons. Since 1 Ni ion gains 2 electrons to produce 1 nickel metal, 160 mole of nickel metal. So, the mass of nickel is C. Find a method to reduce the amount of nickel electroplated. When the nickel is electroplated, the nickel ions are reduced in the PT electrode. Both nickel nitrate and nickel chloride provide the same amount of nickel. So, B and D are eliminated. Replacing the PT electrode with Pb cannot charge the amount of nickel electroplated. However, when the nickel electrode is with a copper electrode, the amount of nickel ions in the solution will decrease, which induces the amount of nickel to decrease. So, A is correct. The Mg nacelle uses magnesium and sodium ion electrodes in electrolyte X. When it is recharged, Mg ions are converted into Mg metal. The discharge is the reverse recharge, so the Mg metal is converted into Mg ions through losing electrons. The electrode losing electrons is defined as a negative terminal. When this cell is discharged, Mg metal loses electrons to be converted into Mg ions. The two potential safety hazards should be related to the feature of Mg cells. This cell has two features, Mg metal and electrolyte X. The cells contain toxic substances. If it leaks these substances, they could damage health. Also, Mg is a relatively active metal, so it may react in the body. The Mg ions are a weaker oxidizing agent than water. If the MgCl2 aqueous solution is electrolyzed, water gains electrons before reducing the Mg ions. So, the Mg ions aqueous solution is not applied to produce Mg metal. To produce Mg metal, we should electrolyze molten MgCl2. The MgCl is placed in a crucible and heated until molten, then a voltage, greater than, is applied on the molten MgCl2 with inert electrodes. Mg metal is produced in a cathode connected to a positive power supply terminal, and chlorine gas is generated in an anode connected to a negative terminal. 8 multiple-choice questions worth 8 marks, and 1 short answer question worth 7 marks in the section on electrolysis and rechargeable cells. The overall score for this section is 15 points. With a total possible score of 120 points, the percentage for this section was 12.5% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Physics channel and Lou's VCE Chemistry channel.